a look at how we find the short side. Get my pen to work. There we go. The short side. So by this stage we should be comfortable with finding the hypotenuse, or the long side, also known as C in Pythagoras' theorem. Now, as we can see below here, we're going to find that one there for our first example, so A. Now nicely, it's in a form that is suggesting what short side is going to take in the equation. So remember, we start with A squared plus B squared equals C squared. And first thing we want to do is substitute our values, so 17 and 15, into the equation. Now the key is we have to remember that 17 is the hypotenuse, and that takes the place of C. Now 15 can take the place of A or B, it doesn't really matter, but seeing as we've got A as our unknown side, I'm going to keep that right there. And B becomes 15 squared. So we can start by squaring 15 and 17. Rewrite our equation down below. 15 squared is 225, and 17 squared is 289. Alright, so algebraically it's fairly simple what we do. We want to get A by itself, so we need to take everything away from that. Alright, and the first thing we need to do, or can do, is to subtract the 225 from this side, and if we do it from that side, we want to do it from the other side as well. Okay, so 225 take 225, gets rid of it there, and keeping it balanced, we do 289 take 225, and that gives us 64. So what we've got left now is that A squared is equal to 64. And remember that we want to get rid of the squared. A is not by itself yet. So the last thing we want to do is take the squared away by square rooting it. And if you do it to one side, we have to do it to the other. We treat both sides equally. No discrimination. And then we get A is equal to 8. So we've now found our short side in that example. We'll slide across and do one more now. So you want to be asking yourself, we know the equation is A squared plus B squared equals C squared. And what place is everything going to take? Now we're going to try and find X. For the sake of remembering that we're finding X, I'm going to change my A squared to X squared. My other short side is 7.6. So that's 7.6. Change my 7.6 squared, and that's all equal to 10 squared. Now, same thing, we want to square everything we can to start with. It's the easiest way to do it. So x squared plus 7.6 squared is equal to 57.76, and 10 squared, pretty simple, it's 100. Alright, now we're going to subtract 57 0.76 from both sides. And we know that that just takes that out, so that's gone. 100 take 57.76 is equal to 42.24, which is x squared. Okay, so if we know that x squared is equal to that, we can square root both of those. Now, square root of x squared is simply x, and then the square root of 42.24 is equal to 6.499. Okay, that's rounded to 3 decimal places. If we wanted to keep it as an absolute figure, we would have to keep it as the square root of 42.24. Now, there is another example that we get, and it can throw some students, and that is if we don't know both of the short sides, but both of those short sides are in fact equal. Okay, so you can see here we've got x, and the two lines crossing there and there represent the fact that both of those sides are equal. So we can look at it in a slightly different way. So to start with, I'll write out our equation just for familiarity. A squared plus b squared equals c squared. Okay, and we ask ourselves, well, what can we fill in there? The easy thing is that c squared is 3 squared, but what becomes of a and b? Okay. Now in the last equation, I changed my a for x, so we could do that again here. And we go, right, I'll change my pen colour to blue. So we can make a x squared. But what becomes of b? Well, b, because it's exactly the same length as x, and x, if x is the same value, we don't want to change the pronumeral. So this side here, we're going to also call x, because x just represents the length of it. Okay, so they're both x squared. Alright, now next we hope that you look back and go, okay, x squared and x squared are both like terms. So what can we do if we've got like terms? We can combine them. So an x squared and an x squared will give us 2x squared, which is all equal to 3 squared. We can keep going with this, starting to work out the things that we know or are easiest to start with. That is that 3 squared is 9, 2x squared. Fix that up. Okay, now how do we get the x on its own? So if we do our undoing BIDMAS, so when we've got something that we want to dig out, okay, so we want to dig our x out of that part of the equation, we take BIDMAS and we're going to work backwards, and we reverse everything with an opposite operation. So from there's no additional subtraction in there, so we can get rid of that. There is a multiplication, so this is 2 times x squared. So the opposite of times is to divide, so we're going to divide this side by 2 to get rid of that 2 there, and we do the same to the other side. So those 2 are gone, leaving us with x squared is equal to 9 over 2, which is 4.5. If you want to go into decimals, you could leave it as 9 over 2. And then lastly, we've got our indice to take care of. Alright, so we can get rid of a squared as we have in the past by square rooting, and that will leave us with x squared is equal to, now you can, and it's preferred in this example, to leave it as the square root of 4.5. okay, as a surd or an absolute figure, because the square root of 4.5 is 2.12132, etc. Okay, so that keeps on going. Now I did make one mistake there when I kept the squared there because I got rid of that earlier. So we want our answer to be represented as an absolute figure, which is 4.5, or the square root of 4.5. And that's how we find, in a couple of different examples, the short side, or A and B, of using Pythagoras' theorem. Cheers, guys. Have a good evening, morning, night, etc.